Assalamu alaikum. Today we are looking at the project that was assigned to us of an obstacle avoiding robot that was using two IR sensors and an ultrasonic sensors. The IR sensors that I have used are the TCR T5000 and the ultrasonic sensor is the HCSR04. Our design was based on the robot that I have opened up in Proteus for you. It was using an Arduino Uno and the sensors that I have forementioned. It was also using a motor driver. The motor driver was the L298N. In this project, we had to do this. The outcome for this project was based on this Arduino reference, and it was doing as such. It We had to make sure that it was following a line using the IR sensors, and when it detected an object using the ultrasonic sensor, it would back up, turn around, and follow the line back to its original position. But to make our project more interesting, we added some voltage sensors, some current sensors, and a color sensor that would detect the color of our object in such a fashion that it also stores the data to a SD card module. We know that the Arduino 32 Atmega 328P microcontroller that is used in an Arduino Uno does not have the functionality of the pins to use that much on single Arduino. So for further help, we were using a ESP32. Our design was based on this photo right now in front of you, and from this photo, you can see we have opted for a PCB layout design on which we can implement our Arduino onto. The next step in this project was to gather data regarding how and when can we manage all of it. That was done by one of my colleagues, and in the next step was to make the PCB. So this was our PCB design. As you can see, these are the Arduino pins. These are the digital headers on the Arduino that are being highlighted right now. This was assigned to the motor driver. These pins also include the TX and RX that use the USART protocol to share data between the two. On down over here, as you can see, we have furthermore pins. This header is our power header. On the Arduino, there is a dedicated power header that lets you provide the Arduino with VIN, but rather also ground and 5 volts to any sensor you require. The header next to it is the analog pin header. Arduino has 5 analog pins. So we had to manage our analog input on the Arduino as such that two of the analog pins these two pins were going to the ultrasonic sensor. The ultrasonic sensor was placed right over here. Like the HCSR04 has two echo and trigger pins that provide us with the calculation of an object's place with a simple formula that was added into the coding. Uh, the next two pins that you are seeing connected over here, this one and this one, were going to our IR sensors. Now, as I have told you before, the IR sensors were following a line. So it was a black line. We know that the IR sensor travel based on the bouncing back of the light, the infrared ray. So we, for a black line, we had to set the IR sensor in such a way that while it was off, the robot was following the line, and while it was on, it was not following the line. Meaning to say, it was searching for its l- for the line. The next part that I want to show you is the codes that were written for this. Over here, we have as the Arduino IDE in which we coded for the Arduino. As you can see, first we have defined our pins, constants, constant int for the pins. This is the motor driver's pin setup, and these are the sensors pin setup according to the Proteus I have showed you right now. In the next step, we had to code our robot. As you can see, our pin modes, we have selected the pin modes that for the pins that we had assigned earlier as input and output on all the sensors, and also given the serial begin, which is our baud rate. Now, for the concept of baud rate, if you don't know, baud rate is the bit rate or data rate at which our microcontroller either talks with a computer or it talks with another microcontroller. This is rather, let's just say, a serial port, like on printers and fax machines and such devices. In the next line, you are seeing a void loop. Now, this void loop is the main code for our robot to follow. First, we had to implement the line following logic of the code, and to do that, we had to first select our sensors. Now, keep in mind that I have told you that our sensors were fitted on the analog headers of the Arduino. That was because these sensors send out analog outputs. So we selected these as analog read. Now they are giving the ATmega 328P the analog data or input. We know that the ATmega 328P has an ADC, analog to digital converter, to get this data transferred. Then we got made an we made a variable in which we were storing the distance. It is another function that will come in the code for the distance. If you can see, the it was based on an if else function telling if the sensor is sending this value, so to turn left or to turn right or to follow the line. Based on this, we can calibrate our sensors or we can change these values to our liking. Now, over here, we were suggesting our distances. If distance is less than 10 centimeter, It will stop the robot, turn around, and move back. But over here is the same case as the IR sensor's value. We can change this distance based on our needs or the criteria asked from us. Next, we made sure for the functions so that we can make the robot follow the line. If you see move forward means that over here we had only written turn left, turn right, move forward, or such functions. We made those functions over here as I earlier mentioned. Now in the move forward function, what we have done is we were turning on both the left and right motors to high so that a robot starts to move forward when it sees the line, turn left when there is no line on the right sensor. It starts to turn left and vice versa for turning right. Now the stop robot function over here comes into action when our robot detects a object that is facing it via the HCSR04 ultrasonic sensor, and the turnaround function is utilized at that time as well. Now, when these functions come into action, our robot turns around and follows the line back, meaning to say that these two functions come into action and then again the rest of the code is followed, like the function move forward, turn left, and turn right. At the end, we made a function of the get distance, meaning to say it is providing us with the distance. As I mentioned earlier, the digital right trigger pin low mm, is sending out a frequency, and it is also receiving the frequency from the echo side of the sensor, sorry. Now we are making up a long variable, meaning to say long is a type of a variable in which we are storing the duration which the the echo pin is giving to the ATmega 328B. And if we divide this duration by this constant, we get our distance. And according to that distance, our robots enacts. The next thing that we did on our project was the interfacing that we had to do. Now I will transition to the other side for showing you the code of the ESP that is storing the data, that is also storing the color sensors data other than the voltage and current sensors data to an SD card module. Over here, you can see this is a code for the initialization of an LCD. This code is written in C, AVRC actually. This is the code for the SD card module. As you can see in it, we have initialized the SD card, file my file, void setup, serial begin, each and everything we were doing. And this is printing to a file right now that is a test file, not the actual file, because the actual code is along the lines. The integration of the ultrasonic sensor, as I told you before, the integration of the optical encoder and the IR sensors is as such, but now comes the time for the integration of the current sensors. As you can see in the current sensors, we have made a simple serial begin function and void loop because our current sensor is also an analog sensor. Remember that. The analog sensor is now taking our our ESP is taking some sensors, right, some samples right now that are then being given to the reference voltage value to be compared. That gives us the actual value of our analog reading from the voltage and current sensors. This is the same way we can apply it to our current sensor and the voltage sensor. Uh, the reason to use an ESP32 is that we are displaying taking the data from our Arduino and the ESP, and then we are displaying it on a web server page. ESP32 gives us that functionality because in ESP32 dev module, we have the ability to use Wi-Fi and Bluetooth. They are integrated. This is the a basic code that the Arduino IDE gives us an example for making a HTML page. So the final complete code of our robot is as such. I have provided the link for these files that I have shown you today on GitHub. The links are in description. Please let me know if you have any questions regarding to that. These are some of the pictures of our project that we have made that I have explained before. All in all, this project costed us around 5,000 rupees to build. That is equivalent to about 60 or sorry, not 60 but rather $40. The project took us more than 4 weeks to develop and implement. We also have open the GitHub file is a public file uh, that lets you develop the file, it lets you further develop on this project if you would like, and a little big by making it by printing it at 150%. That was giving me some problems to insert the Atmega 328P chip uh, right here that you are seeing these headers. After which we were also faced a problem of PCB being not single layer going to a double layer, or we also made this PCB that I use in which I used a generic model of the Atmega 328P in Proteus that caused these pins to be bigger. We also faced problems with the SD card module interfacing as in Arduino IDE. There are some SD card libraries, but those libraries are on a file system that is not recent, and our SD card was formatted on the recent file system. It could have been changed easily, but on the older system, the data gets corrupted sometimes. So we opted to go for the new system. So I had to get new libraries from GitHub and get them onto the Arduino IDE. I also faced a problem with our sensors calibration. They were causing problems while trying to find the line. There was also a time constraint problem for the project, and we also had a lot of components that had been broken by some of my colleagues. In all, we burned around three Arduino Unos while doing this project, as because they were not that fluent in Arduino. They placed they placed power to directly to the 5-volt pins or the ground pins or digital or analog pins that caused the Arduino IDE's voltage controller to burn down and then further burn the Atmega 328P chip. We also faced a problem with the soldering, as these designs require micro soldering, and we do not have the facility for micro soldering, and we had to be very cautious while soldering so that we do not bridge any pins or bridge any gaps. There were also some misruns in the making of PCBs. We also had gaps in the lines of the PCB that was fixed with the help of uh, soldering. And all in all, this project was an exciting opportunity, and we learned a lot during this project. Thank you, Lafis.